only have one after this. Nathaniel
Here.
Daw from Princeton is one of the leads, is the lead for the machine learning core in conjunction with Jonathan Cohen. So
Okay, can you hear me? Can you
we,
see my screen?
yeah,
Okay, everything is good. Okay, so the first thing to say is actually the full title of the core is the Machine Learning Approaches to Mental Illness and Chronic Disease core. These are the leads along with myself and John that Ray mentioned is Yael Niv, who's a professor at Princeton Neuroscience Institute as well. This is the innovation section. So where I want to talk about sort of where this course started and how we're sort of shifting perspectives. So the scientific problem, when we wrote this proposal, it was sort of more of a research project, honestly, which was that, or that was how we construed it. And the scientific problem that we sort of proximally faced was that mental illness and psychiatry have real taxonomic problems with diagnosis. How do you categorize disorders into without laboratory tests? They're often overlapping or heterogeneous, the patients that are classified as schizophrenic or so on. And so our original aims really were sort of research project to attack this in two ways. One, with the informatics core, and we've talked about before, via sort of data mining, patient records, and matching up a questionnaire about that appears in these electronic records about depression, psychiatric symptoms with information about chronic disease state to try to understand if we could better understand the state of the patient and cluster it properly and diagnose properly if we had broader health information. And so that's ongoing. And the other part was laboratory studies of how patients with psychiatric disorders perform at behavioral tasks that we think that our research suggests are indicative of sort of core basic sort of brain mechanisms for decision making and reward and evaluation and emotion. That's with a center called the CCNP, Center for Computational Neuropsychology, which is a Rutgers-Princeton collaboration, which is part of this project and directed by Yael Niv. So what we found out during the review was that we were meant to have more of a sort of service role. And so we're sort of trying to understand and shift gears to sort of have this collaborative research and these particular examples would have it be part of a broader service. And so I thought today I'd talk about two or three kind of more foundational problems that we basically spent the year working on, which were really about building infrastructure. And we think that this infrastructure is going to be sort of more broadly applicable and hopefully useful across more problems and more areas. And so we're looking both to just release this stuff as software and find good collaborations within the CTSA to sort of leverage it and work on it with the problems that we wouldn't have come up with ourselves. So that's what I thought I'd talk about. The first one, and maybe the most specialized to our niche, is that one of the other thing that happened to us this year is that all of our in-person studies got shut down by COVID. And so our whole second aim was sort of wiped out. We had also sort of more generally been interested in the field, have been interested in bringing our behavioral measures online. And so basically collecting large data sets of people performing behavioral tasks via their web browsers. And so we spent a lot of time, and we've had great success this year, basically implementing a lot of infrastructure for recruitment and serving, collecting large data sets and validating subjects and so on, but also implementing these sort of behavioral tasks that can be run in the web browser. So here's a movie of one. People have to choose whether particular robots are good or bad, and they win and lose money for that. And this plays very nicely. And so we've implemented a lot of this, and we think this is certainly, there's been a lot of interest in this in kind of our subfield. People are sort of would really like, and we are going to share all this code, but more generally, having validated robust implementations of these tools that measure things that people want to measure and validating that they work is exciting to people. And I think it's applicable outside of the sort of mental illness frame. So for instance, I was on a working group at the National Institute for Diabetes and Kidney Disease trying to establish core neuropsychological measures in that domain because people are interested in dietary decision making and so on in those illnesses. And the basic finding was that this was missing, that they didn't have the right measures, the right validated measures in this area, and they really needed them. So that part of the report was sort of empty, although it was my part of the report. And so it really showed that there's a broader need there, and so we hope we're filling it. Okay, that was one. Another, and again, coming onto this validation and estimation, specifically in this case, data collected online, but more generally, let me skip actually the second thing. One issue that turns out to be surprisingly tricky is if you are trying to validate some measure and you want to measure it arises from a sort of complex machine learning fit, which these data do, and you want to estimate its test-retest reliability and try to validate your measure. It turns out that basically the mathematics of that are surprisingly tricky. And there have been a number of papers published recently basically arguing that these methods have atrocious performance and the test-retest reliability is unacceptable. And I think it turns out that the problem is not the measures, but the way they were estimating the test-retest reliability. And there's a lot of subtlety and difficulty in large data sets correctly estimating the clustered structure of multiple measures, like the same people tested earlier and later at different times in different patient groups and so on. And so we've worked hard on software for accomplishing this quickly in large data sets and accurately, and I think it's shown it's very widely applicable, and I think it's also shown these particular problems of test-retest reliability, once you estimate them properly, turn out not to be the concern we thought they were, or people thought they were. And the third question, which again I think is sort of very broadly applicable, but we encountered in one particular situation, is that we face these very high dimensional data sets, right? And so we have lists of hundreds of psychiatric symptoms that people report and dozens of parameters from their behavior. We're trying to sort of collapse them down and understand the underlying dimensional or cluster structure of the data. And there's classic tools for this, but they're not very scalable. And they're also not applicable to real data because of things like Gaussian assumptions that scales are continuous when they're not. And so we have worked on and successfully implemented a sort of robust and extremely fast scalable approach for solving these problems more generally that deals with a lot of these underlying issues as well, using something called variational autoencoders, some of the technology of deep neural networks there's a lot of scalable software for them now. And we've got that working well, at least on the sort of basic models. And again, we think this is, the structure of this problem, although we've encountered it in our particular application, is, I think, very broadly applicable. Something like we're exploring collaborations in genomics or proteomics, where you've just got lots of different measurements of lots of different things, and you want to sort of collapse it down to the key sort of correlated dimensions of interest. Okay, so those were the sort of innovation infrastructure issues I wanted to touch on. Now, again, so turning this kind of around into service, which is sort of new for us. One is that each of those things were basically have code ready to release to the world. And I think at least 2 of these 3 will have online this month. And I think in all of these cases, this code will be useful, hopefully within the CTSA and also to researchers at other institutions more broadly, working on things other than what we work on. And then I think in terms of trying to work with people at the CTSA and elsewhere in broadening our collaborations in our service, we have kind of both a service center model in some aspects of it and more of a collaboration model in others. So we've been working on several collaborative projects, more in the psychiatry angle and the relation between psychiatry and other clinical illnesses. And we're sort of seeking seeds as today, if people think they have questions for which these technologies might be useful, we'd be very happy to talk. And then separately, we do have a service center that's running these psychiatric patient studies, at least pending COVID. And we're ramping up the sort of data analytics, machine learning part of that, but it's really with respect to studies on psychiatric patients. So I think between those 2 things, we're sort of excited to increase our reach. So mentoring, again, this is sort of something, we've run a lot of workshops kind of within our department and stuff for people in our field, like how we can apply these methods within neuroscience and psychology, psychiatry. And we're interested in we're figuring out how to mentor students, specific ones that come through the TL1 program who are interested in that. So we have one right now, Jennifer Miles, who's working with us primarily with Steve Crystal, but also with us, and we're trying to sort of figure out what's the right classes for her to take and how to get her tooled up. But I think the sort of broader question is, is there a way we can speak to the broader community, and would the workshops that we run in our narrower niche make sense for other people, and how could we offer that, and so on. And so we're sort of testing the waters there, partly by working with individuals more in the first instance. We were asked about collaborations, and then I think I'm almost done and almost out of time. So again, we have this, we're working on Miles now on her project, and her project is, she's working with Steve Crystal on opioid use disorder. And so we're involved, that project has both a sort of special populations community aspect involving studying patients in group homes, and also a medical records kind of aspect involving Medicaid and Medicare claims data. And via that, and also our original study, we're having a lot of interaction with informatics at all. But again, informatics as well. But again, I think there's a lot of opportunities for other collaborations to emerge, and we're seeking those. And yeah, so our plans going forward are to sort of build out this infrastructure, use it to conduct our own studies, but also to collaborate and distribute this code. I really talked about this. And to sort of try to find training opportunities to help with training and figure out how best to do that. And that's what I've got to say. Thanks very much.
Great. Great, Nathaniel. You know, I think it's really exciting what you've done, and your impression of, you know, open sourcing this to the greater scientific community is really important. It would be nice, I think, if we could get a case use that would be a nice demonstration of what you do, so that we could actually showcase the value added with a case use. And you know, that would be really nice. We would put that up on the website, distribute it in our newsletter, and say, hey, look what we can do. We couldn't do this before, and we're looking for opportunity. The second thought I had is, with your tool in sort of your toolbox, do you need to be able to have somebody interact to investigate a particular outcome, or can you use well-curated claims data? And where I'm going with this, Nathaniel, is we are now part of the NYU consortium that is literally looking at millions of records of patients with COVID. We know COVID is tending to induce greater depression, anxiety, and is there a way that we can leverage your skill set and toolbox to actually address some of this through the consortium? Because as I understand it, you like millions of data points. The more,
absolutely.
Yeah, the more the better. Well, I got them.
Yeah, no, I think that, as I think you and I have discussed a bit, I think there's a lot of opportunities there, and the challenge is just putting together someone like you with domain expertise and ideas about what the right questions are and how to pose them. And I think we definitely, that is one we should and will.
Well, that's great. I think what we need to stand up a case use so that people are concrete about what you can do, that we can then market it. Because I think this is a gold mine, frankly. We just need to know that we have to take the basket off of the candle and see the light. So great. Thank you so much, Nathaniel. I appreciate it.